We are in a race to beat cancer, and one of the most important battlegrounds right now isn't in a lab or hospital. It's inside a computer. A University of Michigan researcher and collaborators from across the country are using high-performance computing to build mathematical models that simulate how cancer grows, virtual tumors that let scientists test ideas they can't test on a living patient.
And so it's really a kind of a zoomed in view of the tumor where each individual element that's in the tumor microenvironment can be modeled.
But when we try to interrogate those models, when we try to ask trust-based questions and really, get at the heart of why the assumptions, what assumptions were driving our output, it was too computationally expensive. So it was prohibitive. People just weren't doing it.
To stress test a model, you have to run it again and again, changing the settings each time to see what really matters.
The reality is it takes hundreds to thousands of simulations to get us enough information to answer these kinds of questions.
Using so-called surrogate models, and that's a fancy way of saying a simpler model that can run really, really quickly, that replicates whatever features of the more complex model that you're interested in.
In other words, build a faster stand-in, learn what you need, and use it to make the big model testable. That shift changes the timeline from weeks to minutes, making it realistic to run the trust checks researchers have been skipping.
Just building that initial bridge between the two models, having that fast turnaround going from 30 days to five minutes is incredibly useful.
Remember, our goal wasn't just fast. Our goal was trust. Right? We know exactly what the model's doing. We know why it's doing it. We know we can be, 95% confident that within these constraints, our model is producing the right outcomes. I think that's, really powerful. As soon as the model gains credibility, it can help guide decisions on how to pace and schedule novel combinations of drugs that will limit the side effects and help reduce tumors in patients quicker.